So, hello children, today we will understand about Ohm's law. So the first question we are going to answer or understand is, it's going to be what is Ohm's law? So what is Ohm's law? So Ohm's law, this Ohm's refers to the physicist who found the law. It was named under the physicist scientist called Ohm. So what did he say? Where is the answer? What did he say? He said that the potential difference which is given by V across the ends of a metallic wire in an electric circuit is very important, is directly proportional to the current flowing through it, provided the temperature remains the same. Not only the temperature, the other factors, pressure also should be the same. So this is called as Ohm's law. So basically he said V is, the potential difference V is proportional to I. What is the meaning? If I increases, V also increases. That is what he said. Provided the temperature is here, what is constant? The temperature is constant. Not only the temperature, even the pressure should be constant. So, whenever in a physics formula you have a proportionality sign, if I want to equal it, I use a constant, proportionality constant. So, he introduced a constant called R. So, here R is called as the constant for the given metallic wire at a given temperature, and R is also called as the resistance. So the formula for Ohm's law is V is equal to IR. V is the potential difference, I is the current flowing through the metallic wire in an electric circuit, R is the resistance. So now what is this R? And also this Ohm's law is, we apply this Ohm's law only to conductors, because we know there are different types of materials, namely conductors, insulators, semiconductors and superconductors. So Ohm's law we only apply to conductors. Then in real life, where you see the Ohm's law. Before talking about the real life application, we will understand better about this resistance. Why there is a resistance? So the next question is, explain resistance. So what is resistance? The answer is here. It says resistance is the property of a conductor to resist the flow of charges through it. So now the conductor is a substance which allows the electric current to flow through it, or which allows the electric charges to flow through it. If that is the case, why, the next question arises, why the conductor show a resistance? Because its property itself is to allow the current to flow through it. So why the conductor shows a resistance? So this is because, you see, we know in a conductor the movement of electrons causes electric current. Also, we know that inside the conductor there are positive charges. The negative charges will move and the current is flowing. What about the positive charges present inside the conductor? So what happens? These positive charges, they provide a hindrance to the negative current. Negative electron provides hindrance. So what is the meaning of hindrance? They don't make the flow of current easy. So here, because of this positive charges which is providing a hindrance, that flow of electrons inside the conductor, they get a hindrance. That is, there will be an attraction between them, no? Because electrons are negative charge and this is a positive charge, there will be attraction between them. That is the meaning of hindrance. So because of this hindrance, because of this hindrance, there comes a property called, this leads to a property called resistance in conductor. So by nature, all conductors, good or very low conductor or very good conductor, by nature they will show a resistance, because inside the conductor the positive charges will show a hindrance to the movement of the electrons. So where is the answer for this question? It is given in the textbook also. Just move forward to the next page. You can see, we know this, see, the motion of electrons in an electric circuit constitutes an electric current. The electrons, however, are not completely free to move within a conductor. Why? That is the question I asked. Why the electrons are not completely free to move within the conductor? Because they are restrained by the attraction of atoms among which they move. This attraction is given by the positive charges. Thus, motion of electrons through a conductor is retarded, and that retarded property we call it as the resistance. This is the answer for that question. So the question is here, why the electrons are not completely free to move in a conductor. So then the one more question is, even if it is a good conductor also will offer a low resistance. So you can take any good conductor, mostly we say the metals are good conductors. So even a good conductor will show a resistance. So that is the reason when you go back to the Ohm's law, we say there is a R coming up in the Ohm's law. That is, we state V is equal to IR. So we say V is equal to IR, where R is the resistance. Now, what are the three ways of writing the Ohm's law? So I will write it here. Three ways of Ohm's law. One is, we know now, V is equal to IR. Then R is equal to V over I, and I will be equal to V over R. These are the three ways I can write the Ohm's law. Now, to understand this Ohm's law better, we will do it through an activity. So let us go back to the activity. Come to the activity 11.1. So if a figure is given like this, so this is a figure, this figure shows that relationship between the potential difference across a conductor and the current through it. So basically this is an activity that shows the Ohm's law, explains the Ohm's law. This activity explains Ohm's law. So we know this is a meter which is connected in series. Here is the voltmeter which is going to give me the value for V. Ammeter will give me the value for current I. So now this is the metallic wire. So now what I do, so I want to basically understand the relationship between the V and I. So this is V, I just refer to the table below. Here I take I. Now first I do the first cell. This is first I connect one cell. When I connect one cell, consider the current is flowing in 2 amps and the voltage you find across the voltmeter is 4 volts. So according to the formula V by I get 4 over 2, that is 2. Then I increase the number of cells to 2. Now I do 2 cells. So consider that time the current is increasing to 3 amps and the voltage is increasing to 6 volts. You find a potential difference using the voltmeter. So again V by I 6 over 3, that would be 2. Next what I do, I increase the number of cells to 3. See 3 cells. So here it is 3. Number of cells is 3. So consider my current is 4 amps and the voltage is V. So that would be 8 over 4, that is 2. Consider I am increasing it to the fourth cell I am using. So consider it is 5 amps. The voltage IC will be 10 volts, that is 10 over 5, that is 2. So now we are going to plot the graph V and I. am going to plot the graph. So when I plot the graph, I take the current in the x-axis, I take the voltage, the potential difference, that is voltage, in the y-axis. So let me take the value. So my I values is 2, 3, 4, 5. So I will go from 1, 2, 3, 0, 1, 2, 3, 4, 5. My potential difference is increasing is 2, 4, 6, 8, 10. So I will do 2, 4, 6, 8 and let me consider it is 10. So when I want to plot it, for it is 2, 4. 2 is here, 4 is here. 3 and 6. 3 and 6. 4 and 8. 5 and 10. So it is a linear graph. What is the meaning? As the I increases, you see, as I increases, V also increases. You see, that's the reason I have a linear graph. So as I increases, my V also will increase proportionally. So this is what found by Ohm. Ohm was saying this through his Ohm's law. He said V is proportional to I. As the current increases, my voltage also will increase. So the same, when you scroll the page, next page, you will find the same graph given for I, current and voltage with a different set of values. But you see the nature of the graph. It is always linear as I have drawn. So you will get a linear graph only. So for this activity, your graph will be linear. So what does it say? You see, you will find that approximately same value for Vi. So come back to the table. You could see in the table when I do Vi, everything was 2. You see, same value for Vi. Thus, Vi graph is a straight line that passes through the origin of the graph, that is origin of the graph. So according to Ohm's law, whatever may be the current, the voltage will increase proportionally, and Vi is always constant. That is a very important one marker. Vi is constant. V by I ratio is always a constant. So this activity proves the Ohm's law now. Now let us come back to the Ohm's law. So we will understand the units for the Ohm's law. So we know Ohm's law is equal to V is equal to IR. So V is given by volt. I, current, is given by ampere. Then what will be the R? So R is equal to V by I. So R will be equal to volt per over ampere. So this, what is volt per? So R unit is volt per ampere, or there was one more unit given to the resistance. It is called as ohm, given by the symbol this. So resistance, the unit is ohm, or it could be volt per ampere also. So there is one more question. Define, the next question is define 1 ohm. Define 1 ohm. What is defining 1 ohm? 1 ohm is when a potential difference of 1 volt is passes through the conductor, and the conductor current through it is, when the current through it is 1 ampere, then the resistance of the conductor is 1 ohm. So this is the question. Next is define 1 ohm. So now we will understand the relation between V, I and R. So for which I will So we will understand the relation between V, I and R. So V is equal to IR. Here consider R is constant. So in this case, when V increases, I also increase. Vice versa, if I decreases, V also decreases. Next, V over I is equal to R. So here always remember, for R, this value is always a constant. This is the constant value. Then I is equal to V over R. Now you should remember this. Here, if you increase the voltage, I will increase provided R should be constant. Please remember that, because I is related to R also. What is the meaning of this? I will increase when V increases. Also, I will decrease if R increases, because they are inversely proportional. So I increases when V increases, provided R should be constant. R is constant. If this scenario is not followed, what happens, we'll see. You see, that is what they say here in this line, that a current through the resistor is inversely proportional to its resistance. That is the meaning, no? I is equal to V by R. Current is inversely proportional to the resistance. So what is a resistor? I will upload it in my next video regarding the resistor and all. So now, what is the explanation? I said, if R is not constant, consider this sentence. You see, if the resistance is doubled, the current gets halved. It's a very important question. Explanation, you see, what does that say? They say, if the resistance, consider, we know the formula is I is equal to VR. Now, according to the question, what they say? R is doubled. That means R is equal to 2R. Therefore, I am going to find the current. That is, I1 is equal to voltage V1 by 2R. So here I say 2R. Then this, how, whenever we want to know it is going to be doubled or halved or tripled, I should take the formula out. You see, V by R is the original formula. So I will take it out like this, V by R. So now that is the reason they say this is half, no. That is the meaning of this. They say, you see, if the resistance is doubled, my current is halved. So current is half, no. VR gives you current. Now I get only half V. V by R is I. So I get only half of I, no. Original I. This is I1, no. When I change the component, my current is only now half the current. So that statement is very important. So next. So now we understood clearly what is Ohm's law, and also remember Ohm's law is for conductors, and when you define the Ohm's law, the keyword should be provided you keep the temperature constant. That is important. Then otherwise you will be losing marks if the sentence is not given, this temperature part is not given. And also you should be very clear in understanding of I is equal to VR also. So this statement, I, if resistance is double, current gets halved, they will give you, it can be 2 times or 3 times, it can be any way. So you should understand this meaning also. So hope this video explained you the complete explanation of Ohm's law. So now we will understand the real life application. Where do we use this Ohm's law in day-to-day life? We use it, you see, we have the fan, no? We have the regulators, no? The regulator where you want to switch the speed. You keep it in 1, 2, is there, no? So when you keep it in 1 speed, the fan will rotate slowly. If it in speed 2, it will pick up its speed. That is, current flow will increase. In 3 speed, current flow will increase. So this fan regulator, I use the concept of Ohm's law. Where using the resistance also. Then where else we use? In fan, Then we use it in kettles. We use the fuse. In home we have the fuse in the main socket, no fuse, and also we use it in the chargers. So these are the day-to-day life applications of Ohm's law. So in my next video I will upload what is a resistor, what is a rheostat, and why we use that in a circuit, and we will also do the next activity also. So thank you for watching my video, and please wait for my next video.